Good day, guys, right? So my name is Babalo Mkhwa, right? So today, basically, we will talk about, complex numbers, right? So complex numbers, just like as the word said, complex numbers, right? So basically, these are numbers that are made of real part and imaginary part, right? Because I'm sure you can remember, if you have a square root of 9, right? So the answer, we know that the answer probably will be plus or minus 3, right? But now let's ask ourselves this question: that what will happen when we have negative square root of negative 9, right? So automatically on the calculator, if you use Casio, it will say error there, right? Because this Casio can only work on image, like only on real numbers. It does not work on the complex numbers, right? So that's why now we introduce this thing that's called complex numbers. So here, what we simply do, the things that are very important if we talk about complex numbers, you just have to make it a point that there are two things that you have to know. The first one is negative I is equal to I, right? So if we put a square root and I squared is equal to negative 1. So this is what we'll be talking about. That if you have an I squared, that I squared is equal to negative 1, and negative 1 is equal to I. So this is the basic things if we talk about complex numbers, right? So now here, we know that if we want to expand this part, we can just simply say 9 times negative, or we can just put the whole thing. We can just say 9 negative. We can just say 9 times negative 1. So what we have done here, because we know that if we say 9 times negative 1, it will give us negative 9 there. So this is what we just done. And the next step that can follow, we can just simply say we put 9 alone, and we put also negative square root of negative 1 also on this side, right? So here we know for the fact that the answer here it will be 3, and just like we talked about it, that if you see negative 1 is equal to I, so this can be our answer here to talk about, right? So what you have to do if you talk about this thing, guys, first and foremost, you just have to expand the number that you have there. Once you expand it, then you make sure that you make use, of the very basic things that are very important on the complex numbers. That you know that I squared is equal to negative 1, and the square root of 1 is equal to I squared, right? So I just got two examples that I want us to talk about this side, right? So as you can see, right, so we have negative 3 plus 2I, right, and minus into 2 minus, yeah, is it minus? Yeah, I think sorry, it's plus 4, plus 5I. So here, as you can see, guys, these are two different things. There's a sign, an operator that is here. So we're going to put this first bracket alone. So we will have negative 3 plus 2I. Then we times negative, negative 1 times. So here will be negative 2 minus I. So what we'll do the second step, we collect the like terms. The one that got I, they go together, and the one that are real numbers. Because anything that got an I, it's called the what? Imaginary number. And everything that's those one are real numbers. So if you say negative 3 minus 2, negative 2, then the answer will be negative 5. And if we say 2 minus 5, so the answer will be negative 3. Then we drop also the I. So this can be, the very basic things that we talk about. And because we know that it's A plus B I, right? So this is how we should know. This one stands for real part, and this one you just have to know just like that, right? So even if we can talk about this one, because here basically, if you talk about this one, you always talk about you have to use foreign method, right? So but now if we talk about here, as you can see, we have got negative, square root of negative 16. So first and foremost, what I will do, I would first, make sure that I remove that negative sign here, just like the way we did it here. First, if you have negative, square root of negative 9, you expand, right? So we said 9, you drop the 9. But if you said 9 times negative 1, that answer there will give you -1 will give you -9. But now we just take out the 9 because we know this thing and this thing, if you say square root of 9 times negative square root of 1, it will give us, we drop this one will be 3, and just like here. So even here, what we'll simply do, we'll just open the bracket and say square root of 2 minus, and if you get here, you can expand and say this is 16 times -1. You close the bracket, you open another one, this is square root of 2 plus, it's 9 times -1. You close the bracket, right? And also we can also go back again and say, okay, as we know that if you said it's -2, so this will be 16 -1, and also here you have 2 plus, this will be 9 -1. So here I'm sure you can see that what will happen first, right? So just like we talk about, if you see anything that is known as negative, square root of 1 is equal to, is equal to I there. So if you talk about here, we can just say 2 minus, so this one will be 4I, and we also, this will be square root of 2 plus 3I, right? And we talk about FOIL method, right? So here, we start with the first, these ones, and we also talk also these ones, and then we talk about this one, we also talk about that one there. This is what is called FOIL method. So here, what we have to know, guys, if you say square root of 2 times square root of 2, right? It's easy because if you are timesing and the number that you are timesing, the same, you just, because if you say square root of 2 times square root of 2, the answer will be, if you say 2 times 2 will be 4, square root of 4, then we know it's 2. Then we just put 2 here. And you say it's negative square root of 2 times I, then here will be plus 3, yeah, it will be 3I, then you can just put us, no, let's do like this. We can just put square root of 2, 3I. No, it does not make sense. You can just put, let's put 3I square root of 2, right? So if you talk about this one times negative 4I times square root of 2, then the answer will be negative 4. No, yeah, it's negative. Then this one times negative, what is that? It will be negative, I think it's 12I squared. Right? So from there, what we talked about, we collect like terms. Guys, if you talk here, we said the most important thing if you talk about complex numbers, you just have to know these two things. That whenever I see an I squared, that one is equal to 1, right? And normally, sometimes you can get an example whereby you are given, I to the power of 5, right? Even that one, you have to make sure that you break it down to get to this point. We know that if you say square root of 2, if you say 2 to the power 2 and 2 to 4, because what we saw in maths, if you put a bracket here, basically this thing is same as like 2 times 2, which is 4, and here plus 1, which is also 5, right? So you can also break down and say, oh, okay, but here I know, which is very important. If you talk about even numbers and also odd numbers, if the exponent here is even number, that is, you can divide that number by 2 and there's no remainder, you just drop this -1, and here will be 2, and the answer that you can get here automatically 2 is already there. So 2 times 2 will be I there, right? But we'll talk about it in details when we get there. For now, we are just here, right? So from here, what we talked about, guys, we can change this one. We know that we have 2 plus 3I minus 4I square root of 2. Then it's -12 to the -1, because we talked about it. I squared is equal to -1, right? So the next point that you can do, right? So if we say negative times negative, it will be positive. So you can sort of like say, okay, what I will do here, I will combine these ones. So if you say 2 plus, so color, okay, mankan pala yona. So we have 2 plus 3I which is 2 minus 4i, which is what? 2 minus 12 negative 1. Okay. Yeah, I think it's proper now. Okay, my wait, I just want to write about. So what you can simply do, guys, right? Because remember, we talked about this, that, if you talk about complex numbers, the format that you have to know is just it's a plus bi, right? So anything that does not got an I, that is your real number, and anything that's got an I, that is your imaginary number part, right? So here we know that, we have eliminated I there, right? So if you say 2, because this is negative, so negative times negative will be positive. So here, basically, you can just say we have plus 12, right? So if you say plus 12 plus 2, so the answer here will be 14, right? But now I just want to talk about this thing. If you check on the one that on our imaginary part there, right? So we've got something that is common there, right? And the one that we can talk about something that is common, because we know if we can take out this I, you can say plus I, then you are left with 3, 2 minus 4 square root of 2. Right. So what we just did, guys, we just take out an I, because so that it can be easy for you to use it on a calculator. Right. Because if you say negative, if you say 3 to the square root of 2 minus 4 to the square root of 2, you can use that thing on a calculator. Then whatever answer that you got, you just multiply with the answer. Because anything, if they said you should leave your answer in standard form, this is the standard form that we talked about, right? So here, simply we can just have 14 plus, so what is the answer if you, like if you combine everything here, combine everything. Like if it says 3 to the square root of 2 minus 4 to the square. Oh, okay. I know what you did. So we can just say I there, my minus square root of 2, right? So what we just did, because remember these ones are the same, right? So we just minus this one there, right? So but now this is a negative sign. So if we are going to say negative 14 with times here, it will be negative square root of 2i. Right, so this is what we did here, right? So first and foremost, first, just like we talked about here, first, you just have to make sure that you eliminate, that negative sign, because there are other ways. Other students can say, what I will do, I'll just say square root of 2 times square root of 2, square root of 2 times negative square root of 9, But before, the easiest way out for me is to just make sure that you expand the one that got a negative sign, you expand the one that got a negative sign there, right? But whatever method that you think it's easier for you, right? So another thing that, guys, we can talk about, if you talk about complex numbers, right? We can talk about, because remember, if you have something like this, right? For instance, if I'm giving you a question like 3 plus 2, okay, if I give you a question like this, right? So right? So you know that, okay, I'm able to plot these values, right, on my diagram, right? So basically now we are going to talk about anchor diagram, right? So which is very important. If you talk about it, automatically we talk about polar, then they will, because remember, an examiner can ask you that, the answer that you got here, you should make sure that you leave your answer in polar form, right? Because this one is the standard form there, right? So here, there are very basic things that we talked about. So on this, let's just make a use of any example that we have. I'm just thinking of a number now, guys, right? Because here, what is very important, normally, we know that this is our y-axis and this is our x-axis, right? But now we talk about, complex numbers. So this one, the x-axis become our real part. This is our real axis. And, the y-axis, right? So this one become our imaginary axis, right? So it does not change, still the same. So for an example, if we have 2 minus 3i, right? So when I want to talk about, for the fact this one is my real and this one is my imaginary part, right? So you go look, okay, on my imaginary part, I know on my real numbers, anything from, if this one is 2, which means it's positive, right? So you ask yourself, where on my real part does I can get positive 2? So real numbers are only positive on first quadrant and also on the fourth quadrant. Right? So this is what you ask yourself. And also you ask yourself another thing, okay, where can I find, well, this one we talked about it, that this one is an imaginary number. So where can I find an imaginary number? But my imaginary number must be negative. You come here, you look at the one that is vertical. Okay, you say, oh, okay, from here going down, I know if you have 1 here, it will be 2 here, it will be 3 here. If you have 1 here, it will be 2 here, it will be 3 here. But if you have 1, 2, 3, but here it will be negative, and going down it will be negative 1, negative 2, and negative 3 here. So for sure, if you can look, if you talk about imaginary part, they are negative on the fourth quadrant, and also they are negative on the third quadrant. And the place whereby you got, the 2 stars, this is where your ant diagram will be. Then you look, okay, so here this is my positive 2, and also here this is my negative 3. You just draw a line, sorry, it's supposed to be straight, like this, right? So, but now, guys, what we have to important, if we talk about polar form, there's a formula that is very important for you to know. We talk about R, cis, and other people, they can talk about R, cis, theta. So this one, guys, it's our modulus, and this one is our argument, right? We know if we talk about angles, because here we can know, okay, if this line is coming here and here, so which means automatically here, I can have a chair, right? So if you have a chair, if you talk about the right angle triangle, this is the kind of triangle that we have here, right? So this one can become your opposite, and this one can become your adjacent, and this one can become R. This is the distance that we are interested on. This is the distance that we want. And we know from Pythagoras theorem, right, that if you have this value from here to here, we know it's 2, and from here down here, we know it's 3, right? So here you can make use of Pythagoras theorem and find the value of R, right? So R, we know that if you say R, which is the real part, x plus y, but you squared, right? So this one that we talked about is Pythagoras theorem. So the value of x automatically is 2 squared plus negative 3. So this one will be 4, and here it's 9. So I think it's 13. Yeah. But here is squared. Then if you say squared, then r is equal to square root of 13. So the distance, this angle, this line, this length, guys, is always positive. There's no way whereby you can have a modulus that is negative. If we talk about modulus, it's always positive. So we know that, okay, from here to here, it's square root of 13, right? But now what we are interested on is to find the angle, right? From here all the way to here, right? So because we know here it's 90, we know here it's 180, we know here it's 270, and we know here it's 360, right? And now we ask ourselves and said, okay, so what we have to know is from this part, if it's on second quadrant, it's -80 minus, then it's d over a, but here it will be 180 plus tan theta, then it's d minus all over a, I mean. If you talk about this one, it will be 270, sorry, it will be 360 minus tan theta, then d over a. Right, so this is what we have to know. If you want to calculate, because I want to calculate the modulus, our angle. If it's here, it's just simple. You just take the value of B. What is the value of B? This is the value of B. This is 3, and this is the value of A. right? So you use the calculator, you can find the modulus there, right? But now, if your modulus is on the second quadrant, if you have a diagram on the second quadrant and you want to find the angle, as you can see, this angle here, it's 90. So if it's here, it simply means that it's greater than 90, but it's less than 180. That's why we talked about whatever answer that you got there, you minus that answer to 180 there, right? B will always be an imaginary number. It does not change. And A always the real number. It does not change there. Right? So if we talk about this one, it's simple. This is 180. So 270. So you know for the fact on my third quadrant, any angle that I find here, it must be greater than 180. But that angle must be less than 270 there. Right? So based on what we talked about here, we know for the fact that our own ones, it's here. So it will be 360 minus 10. Then we talk about the real part. Because when we talk about this guy, we ignore the negative side. So you don't put up a negative 3, you just put 3 divided by 2. Then whatever answer you get, that is your answer there. Then that answer will be less than 360. Then you minus, then you get your R there, right? Then these are the formulas that you have to know if you talk about. But now, the thing that is very important, how can you change? Because this is a polar form, this is a standard form or rectangular form. How can you change this one to polar form? You always talk about R, cos theta plus I cis theta. Right? So also talked about this one. That for an example, if we have something like this, in a standard form, and the examiner asks you that you should leave your answer in standard form, leave your answer in polar form, right? So this is the formula that you have to make sure that you make sure that you use, guys, right? So it's very important. And therefore, another thing that you have to know if you talk about these things, because sometimes you can be given an equation whereby it's 3 over, let's just say 4 plus 3i, right? And they say, you should leave your answer in standard form, right? So what is important here, guys, if you have a question like 3 all over 4 plus 3i, right? So we always talked about this, because there's something that is very important that we have to talk about, which is called because here, what we can all do, right, we will have our 3, right? But now we ask ourselves, how can we rationalize this denominator that we have to a point that everything that we have on here, it's only real part, right? So that's where we talked about that, okay, if we have, let's talk about this one, if you have 2 minus 3i, right, and you want to and they say this one is equal to z, right? And they say go out there and find the value of, put a line, this one, what you have to know, is simple. That my value that is real does not change. The only one that will change the sign is only the one that is imaginary. So we're just going to say 2 plus 3i. What I've done here, because remember, this is z. So if you get z, this is conjugate of z. But automatically the examiner can just put a line just above, z there to see that this is conjugate. So if you want a conjugate of that number, what do you do? On the one that is real, it does not change. We just drop the 2 as it is. But now this one is negative 3i. We just change the sign from negative, it becomes positive. If it was positive, then it becomes negative. So this is what we will do also on our part. As you can see, our imaginary, this is real part, and this is our imaginary part. So we take the equation as it is. Then we write the conjugate, which is 4 minus 3i. We talked about it. A conjugate, a real part remains the same, imaginary part changes the sign. It was positive here, that's why it's got a negative sign here, right? The first important thing that you know in maths, because whatever you did, as a denominator, it's very important also on your numerator you must also make sure that you do. That is, you can do anything you want on equation as a denominator, as long as you do that thing, on the numerator there. Yeah, this is what we are doing basically. And here we know for fact, if we say 3 times 4, this one will be 12. 3 times negative 3i, then it will be 9i, right? So what we have here, it's very important, guys, right? So just for the quick one, if you are having, right, let's say that, let's just put that thing as the whole. If you have negative 3, sorry, it's 4i squared plus 4 negative 3. Right. So you have to know this thing by now, right? Instead of you using FOIL method, you come and check, okay, my outer value and my outer value are the same. And you talk about the last part and the last part, they are also the same. The only difference between those one is the what is the sign. What I will do, I will take this one and this one and also this one and this one. So if you say it's 4 times 4, it will be 16. 3i times negative 3 will be negative 9i squared. Right. So what we have done here was, remember, here we say 4 times 4 will be 16, and we say 4 times negative 3 will be negative 12i. Then we say negative 3 times 4 it will be plus 4i plus 12i squared. Then 3 times 3, 3i times negative 3i will be negative 9i squared. As you can see, these ones, they cancel each other. You are left with 16 minus 99i squared. Right? So this is what we did here. But you have to, it's not always the case. You have to look at my first term, are they the same? Okay, they are the same. You look at my last term, are they the same? Or they are the same. What is the sign between those brackets? Okay, it's positive, it's negative. It is positive, it's simple. I take the first one and the first one, I take the last one and the last one, and I maintain this sign here. Because we know that if you have a negative times a negative, that one will be a positive. If you have a negative times a positive, automatically it will be a negative as it is there, right? So that's why we took those negative and we drop it here, right? So from here, we know now, right, it will be 16 minus 9 I squared, right? We talked about it. We said, guys, whenever you see, if you check on the first example there, whenever you see an I, because remember, the reason why we multiply everything by conjugate, it's because we wanted our denominator to have a real number only. So if we have multiplied this part that we have and you conjugate and you still have somewhere an I, which means there's something wrong that you did here, right? So what we'll do here, it's simple. We just put 12 minus 9i all over 16. We maintain the negative. And here we know that I squared is equal to negative 1. So here we're going to have 12 minus 9i. Then we know negative 9 times negative. What I just did here, that a negative times a negative, it's positive. So here we have 16 plus 99, sorry. Right? So from here, it's 12 minus 9i. Then you just combine this one, 16 plus 9, I think will be 25. Then it's 25. Remember, the instruction that we got was said that you should leave your answer in polar form, in standard form. So it's A plus BI. This is the standard form. Right? So what we do here, it's simple. Right? We just say 12 all over 25 minus 9 all over 25. Then that is I there. Right? I'm sure there's a common factor that you can find. But if you can use a ratio, it will simplify things for you. Right? But yeah. High 523. Yeah, you can just leave it like this, right? But you have to make sure that you follow the instruction. If they say you should leave your answer, like this, or say, or they ask you leave your answer, as a decimal, then you just, make sure that you follow the instruction that they talked about there, right? So that is what I want to talk about. And another thing that is very important, is that sometimes you can be given an equation whereby you have 4 6, let's just say 45, all over, let's just say put 5, 6, 102. Right. And the question can say, you know, determine and leave your answer in polar form. Right. So for automatically, we know here it's already been on polar form, guys. Right. So it's 4, 6, 45 all over 5, 6, 45. So what we do, it's very simple also on this one, right? Because remember, well, there are two ways of doing it, right? Another one, you can convert this one to be in, but it will take a long time. So the easy one that you can just you can just say 4 divided by 5, right? So the most important rule that is important, then here you can just have 6, because you open 45 minus 102. Right. What we did, guys, we divided 45 divided by 5. We've got 4 over 5. And here, the rule that they talked about, right? If you talk about your argument, right, you can't say 45 divided by 102. No, you can't do that, right? So what you will do, you just take 45 and you minus the argument that you have as a numerator, you minus it as the one that you got as a denominator. So the answer that you can have there can be 45 over 4 over 5. Then you write your 6. Then you subtract the 45 minus 102. What can be the answer? Yeah, but whatever answer that is, but that answer will leave you a negative value there, right? So you can be able to convert it. But on level 3, I suppose to take this one as a numerator so that this one can be a denominator. But the idea here, it's very important that if you talk about my modulus, I divide this one. But if I have a division sign, what do? This one, my first argument, the one is a numerator, I minus it with the one as a denominator. Right? So in an example whereby, let's just say it's 4, 6, 45, and they say multiply by 5, 6, 102. Right? Also, even here, guys, what we do is simple. Because remember, here we divided. So if you talk about the multiplication side, what do? We times. Because this thing, it's like R1, then we have argument 1 times R2. Then we've got our argument 2 there. What do? We times our modulus, but this one argument, what do? We add them. So here will be 4 times 5. We write our, 6. Then we say 45 plus 102. 4 times 5, I think the answer is 20, and you just add these ones. You get your answer there. Right? Any questions? Eh? It's 147. Yeah. Yeah. 57. Okay. Right. So this is the idea. If you multiply and your equation is on polar form, the one your modulus, what do? You multiply them, and what do you do with your argument? You just add them, just like the way we did here. Let's go.